All right, so what you're looking at now is the Xcode IDE, and this is the Apple development system. Okay, so you're looking at the home screen of the game that's in front of you right now, and the program is broken up into 6 classes. There's the home scene class, there's the main scene class, there's a space class called physics body that I created, there's the dice class, there's the floor class, and then there's the image class. So if we go to the the home scene class is what generates the screen you're looking at right now. Okay, and I have an include file that I call MSC constants, and that's where I keep general purpose constants that I use throughout the program. I can keep them all in one place. So let's look at the home scene. This is the definition file. Notice it's deriving from layer color instead of layer. This is because I had to change the background color of the screen. Okay. Here are the 2 buttons that are defined, one to exit and one to play. So it's actually quite simple. All right, let's look at the implementation. And you'll see, here's where we're defining things. Here's where we define the exit button. Here's where we define the play button. Here's where we're defining the sprite, which is the home screen. And here are the callback methods that handle the when the buttons are pressed. So when the exit button is pressed, this method gets called. And as you can see, it exits the game. And when the play button gets called, it's calling this method called play click, which plays the sound of the button click. And it takes the main scene and it calls the method push scene, which pushes the current scene, which is the home scene, onto a stack, creates the main screen, and brings that to the foreground. Right. So we'll look at the play button click. You'll notice that not only am I playing the effect, I'm also setting the volume. This is because each one of these files, these sound files, are at different volumes. So you want them all to be at the same volume. So none of them really dominate over the other. And that's what I'm doing by setting the volume of this particular one. Okay. So again, that's the home screen. All right. So let's get into main screen. All right, here is the main screen. And let's go to the main screen definition. Okay, so you'll see that we also derive from layer color in the main scene. And that's because I needed to make the background this color. And the only way you can do that is by deriving from this class. All right, I've defined 2 enumerator types. One for the bid status, that down here where it says make a selection. And one for the status type, which up at the top displayed winner or sorry. Okay. I have some constants defined. These are flags that I use to navigate through the program. And here are the data members that hold the physics information and the pair of cubes with the smiley face and the sad face, the dice cubes that you see here, just above the make a selection. That's the C image sprite, that's the image one. You'll see that there's a floor. Okay, that's what this is down here, that the dice is sitting on. And then there's a boundary which is superimposed on the image of the floor. So when the dice roll, they're not really rolling on the floor, they're rolling on the boundary. But that also happens to be of type C floor. Now the reason why I separated these two, it had to do with the position settings of the floor. I was having problems trying to coordinate that with the boundary of when it falls off the floor. So in order to get it to work, I had to make them two separate items and just put their positions so they overlap each other. All right. These are the callback methods for the exit button, odd button, 7 button, even button, and speed up button, as you can see here. 3 buttons at the bottom, the button at the lower right corner, 2 at the top. Here are the methods to play the sounds. Play the win sound, the sorry sound, the button click, the rolling dice sound, the falling dice sound. This is the tick method that gets executed on every frame, and that's how the physics operation is performed. Update status determines whether the word winner or loser or sorry is displayed up at the top. And these two methods down here, return bid text and return status text, return a string based on an enumerated type. All right, accordingly. All right, so let's go look at the implementation file for the main scene. Okay, so we'll start here at the top. You'll see we have a constructor and destructor, and all the variables, data members that I created, the floor, the boundary, the image, and so forth, those classes have to be destroyed and deleted so the resources are freed up, or else we'll get a memory leak. And the init file is where I start to create the screen that you see here. So I'm going to move the code just above the viewing, just above the screen, so you can see what sections are being done. Here's some initialization to get some system information. Here's where the physics world is being created, as you can see here. Now here's how I'm creating the floor, or the platform that you see there, the white line that the dice is sitting on. As you can see, it's only a few lines. Okay, that's because it's using a special class that I created called physics body. Now, if I didn't have physics body, I'd have to do this code that you see here for create body boundary for every single one of the items that you see on the screen that's a sprite. So I left this code here so you can see what's involved and to see the difference between this here, only 3 lines, or this here that has more than 10. All right, plus it encapsulates all the effort for the particular sprite. It's encapsulated into the derived class, where here it would be spread out throughout the entire main scene class. All right. So here's where the images get created. As you can see, I'm setting up them with their own world in Gravity. This is because of the idiosyncrasy of the physics engine not being able to distinguish when something is hidden or when something is visible. So even though it's hidden and it's out of sight, out of mind, the physics engine still thinks it's there and it tries to operate on it. So this created problems with the falling of the cube, the dice cubes. So I had to create its own world and set that equal to these image files. That way they're transparent to each other, and the falling dice don't even know that those cubes are there, and vice versa. Okay, here's the code to set up the status label that you would see up top. Right now it's blank, but the label would be between the exit button and the roll button. There's the bid label that's down at the bottom that says make a selection. That's where you would see odd, even, or 7. Here's the code for the exit button. As you see, exit button. Right. Here's the code for the 7 button. Very similar to the code for the exit button. The only difference is it calls different callback and the image file is different. And its location. All right, that's the odd button. Creation of the even button. Creation of the roll button. Here's the special speed up button. Here's where I define the music. Notice that not only do you have to load the music, but you have to tell it that you want to play it in a loop. Okay? And you want to set the volume of the background music because the music is very loud and you want all the sounds to be at the same volume or some lower than others based on the concept of the game. So you need to control the volume. All right. And that's it. Here's where we schedule the tick class that executes every frame. Here's the touch method. All right, the scene is created. Here are the methods that I talked about that you pass it a enumerated type and it returns a string. You can, as you see, you can recognize the strings. Same thing with this method. This is a method just updates the display. I pass it the enumerated type, and then it sets the variables and the string and everything else. Now this is the tick method, and this method gets executed every frame. So you notice I'm looking at the collection of all the bodies that are in the world, and it's in a for loop. And now I'm going to walk through each one and apply the physics to each one so that it can do the motion of falling and rotating and so forth. Now there's an if-then condition here that checks to make sure that the items, once they leave the screen, the view of the screen, you need to destroy them. And that's what's taking care of this. This is the navigation variable, dice have hidden. I'm incrementing that, which means it located the dice, and the first dice was removed. And then when this gets to 2, that means that it's time to display, it's time to process the status information, whether the person won or lost, and to disable the flags that disable the buttons, and so forth. All right, process status information. This is where I determine if the person won or lost. So we're taking a random number generator, and we're grabbing a number between 0 and 7. So that would be the 1 through 6. Then we pass that through to these methods that I created, set image, and they will take this number and display the appropriate die on the image file, on the image sprite. Then we take those two numbers, add them together, and here's where we determine if they won or lost. So if the person selected odd, we do this check, and if it meets the criteria, we update the status to winner, and we play the winner sound. If it doesn't meet the criteria, we update the status for loser, and we play the sorry sound. Same concept used for even bid. Same concept used for 7-bit. And here's where we make those image sprites visible again. Here's the play button click method. You'll notice again the volume. Here's the play winner sound method. You'll notice the volume setting is different than the press button because they're all at different volumes. And you want to make it all consistent across the board. These are the methods that play the sorry sound, the rolling sound of the dice, the falling sound when the dice are falling. Here's the exit callback that takes you back to the home screen. And the way it does that is that first it stops the music, the background music. And then it pops the scene, which removes the home scene from the stack. The main scene gets destroyed. And the home scene gets brought to the foreground. Here's the callback for the 7. Notice I'm checking for a flag called disable rolls. That's because you don't want them to change their bet while the roll is going, and you don't want them to continuously be dropping dice. So all the buttons are disabled during that point. Here's what to do when it's odd. All right, as you notice, I'm setting the string in the bid label. Same thing for even. Here's the special speed up. Here's the rolling button of the dice. As you can see, I'm creating 2 sprites, dice number 1 and dice number 2. Notice that there are only 2 or 3 lines here that are actually doing the creation of the sprite. And this is because of the special base class that I created. All the work is done in the base class, and all I have to do is derive from the base class and then just add whatever additional value I need to the physics sprite. All right, and that encapsulates everything, and we'll look at those files shortly. That takes care of the main scene. All right. And now we'll move on to the other classes.